Okay, I'm recording.
Okay. Well, welcome to FRC Java Programming. This is part one of a part two series. I am your host, Eric Weber. I am a member of FRC Team 1322, the Great Leviathans, FTC Teams 5954 and 7032. One of the biggest things I would like to just say is that you have the power as programmers to be able to say that you're to determine if your program on your robot will run and do autonomous mode and do everything that your team ever dreams that your robot can do. So, at the very least, it's all about just making sure you have enough discipline to be able to see through your entire project, get it completed, and then also learn something and have fun. So, with that said, let's go ahead and talk about a little bit about the Java history. Well, quite simply, not to mince words, Java was initially meant for multi-platform devices, and in our case, we have a robot controller that can run the virtual machine inside of it, and also be able to read whatever we throw at it. So as long as it meets certain criteria, which we'll go over in a little bit. And it was originally created by a guy, and his number one goal was to make Java as open source and as transparent as possible, so that way the language could expand pretty quickly, and it did. Even up until today, it's still considered the largest programming language used ever, beating out C++, and PHP, Java. Well, the important thing to know, do any of you guys know if your school provides computer science as an AP class? Great. Guess what?
Java.
Learn Java. Because
Java.
that is actually what they use. So, more importantly as well, going beyond the scope of today's presentation, once you've learned how to use Java, you can apply it to a lot of different other programming languages, such as C, C++, C#, Python, Ruby, Pascal, many others. Many other flavor of the year programming languages that pop up. Now, to be able to program for at least this previous year, you have to follow these step-by-step instructions in these websites. The first website here, listed here, will teach you how to and walk you through installing Java on Eclipse, which is the IDE that we use. IDE stands for Integrated Development Environment. Then the second website here will talk about on the FRC 2016 suite, which will allow you to set up your robot controller, also provide you with a few other tools to be able to run your robot. So just three basic definitions that we need to go over immediately is IDE, which is the Integrated Development Environment. Eclipse itself is an IDE. It contains the source code editor, a compiler, and also a debugger, all roll up into one nice, neat little package. You can do all your coding in Eclipse, but if you are in a pinch and you just need to write code anywhere, you can always just use Notepad, just to write it. Or if you're really looking to be industrious about it, I suggest installing Notepad++ on your computer, just if you need to write some code and don't have access to Eclipse. Op modes. Well, in FTC we have a thing called op modes. It covers anything from autonomous mode to teleop mode. Well, in FRC, everything's rolled up into one program. So if you have an autonomous mode, it has to be encapsulated inside the same program as your teleop mode. And also, finally, keywords. Keywords is a term meaning that Java holds certain words that you cannot use, primarily due to the fact that the compiler requires those keywords to be able to discern what you actually want to do, and we will go over those pretty quickly here. And you can't use them as a unique name. All right. So let's go ahead and just dive right on in. Now, this base code that we are going to be writing is going to be very minimalistic. It's going to be the shortest program that you'll ever write for FRC. And quite simply, we're just going to make some kind of drives on a drive system. And then we're also going to create an ARM, or a shooter if you will. But the problem is that you'll run into, at least when it comes to this style of programming, is that it's not good for teams. If you have a team of one or two on one programmer, you're fine to use this. Go ahead and use this methodology of programming where you put everything in one file. It's fine. But as you grow in size as a programming team, 2, 3, 4, 5, well, there will be limitations due to the fact that you're all going to be working on one file. So it's not really effective for teams. But if you need to get some kind of test bed up and running, test a motor out, test some, like a shooter out, test some basic code, this is a great way to just test. And if you've actually programmed in C++ before, you'll be pleasantly surprised that you are going to be missing a lot of items that you don't have to work with in Java. For instance, you never have to deal with pointers. Pointers are gone. You don't ever deal with pointers in Java. So it makes it a lot easier in that regard. So just and I know you guys can't see that, but this is what you're going to be writing. Now the great thing is, for those in the back, it's going to be hard for you to see, but you'll notice that there's at least some color involved here, and it's nice that you'll see that when we get into this, things are going to be try to be crystal clear. So this code will allow for a very simple autonomous mode and teleop mode. And so we're going to just go over the basics of both. Also another thing, if you have a lot of Talon SRXs, this is a great way on this code will work directly for you guys. However, if you don't, you can use whatever motor controller you want. And we're also going to look into the robot drive class for the drive system as well. It's a great way to just get things working, and even when it comes to your drive system for your actual on your competition code, you might find that it's really useful to just use. It's nice and simple, and it works. All right. Now let's start looking at the code line by line. Now, for those of you who do not have access to the WPI library because it's not installed, I'm sorry. Your life is going to be a little bit more difficult, but you can still type everything out for future reference. There will be a lot of red squiggly lines if that's the case, but it'll all work. Now, most of these items, we're going to import automatically. Now, down here, can you guys see it in the back? Okay. The biggest thing here is to know what we have at the bottom here. We have, for instance, we have, oh, come on. We have this set right here I'm talking about. We have Talon SRX. We're going to set up a left drive and a right drive and an arm. We have robot drive, which we're going to feed some of these motor controls into. Joysticks, and some kind of a timer. Alright, so let's go ahead and write some code. Okay, let's pull that out.
Now, class represents a certain kind of program?
We'll get into that in a moment. One moment.
Okay.
Oh, you guys can see this. All right, great. Super. All right. So, yes.
Where can you find the WPI library?
Okay. You can find that right here. Well, you have to follow the steps in here, right in this middle link right here.
Okay.
You have to set up Eclipse. Then you have to point Eclipse to the repository for the code for the plugin. Download it, install it. It does take a little bit of time.
So it will be there after you do all that. It'll be like in your files.
Yes.
Email it to us, we've got email it.
Right, now, isn't it on these computers already?
I don't know.
Okay, I think it is.
Yeah, it's on some of the computer
Yeah,
networks.
right now, most of these computers should have it.
I graduated this term on this year, so I haven't been on campus at all.
Mine doesn't, but that's my personal one.
So
Put it on.
these computers should have and might have it, but they might not. I know I did get some of these for last year. I did get some of these front ones completed. But I digress. Now, one of the cool things that we're going to talk about is something called autocomplete. Now you'll notice that right out the back we have a lot of things here that we don't have, and I don't have in my code. And that's fine. We're going to add stuff. So instead of, so what we're going to do is we're going to start programming down here below this line 16. If you have the default code, you'll have this line called public class robot extends iterative robot. That's a mouthful.
Should they have that up now? No, we have
Okay, so to get here, if you have, if you guys do have on the WPI library, here's how you can get here. Thank you for stopping me. Go up here to File.
First they gotta open that WPI.
No, they just got open Eclipse. Either you have it or you don't.
Eclipse.
Eclipse. There's an icon.
Is it, I'm just in the clip, but it doesn't say Java.
If you're looking for the icon, it looks sort of like this. Any questions? Issues?
Preset out what yours is later. Wait, did you just click on it?
You guys need to work in pairs. Programming also does work in pairs.
Help each other. If you want to go and look around at some of these,
Well, either you have it or you don't.
but they may not know how to get to it.
Okay, you guys are good there, you guys are good, look like you guys are good there. Good enough, good enough. You guys look compared. Good.
One moment. We'll get there. I'll go step by step. But in reality, guys, working in pairs actually does, in the professional world, actually does increase productivity. You might be working one at a time, but you actually do find more bugs sooner. All right. So to get to once you have Eclipse open, you should be able to go into File, New, down here to Other, and then you should have access to, at the very bottom here generally, is two folders, WPI Live Robot C++ Development and on WPI Live Robot Java Development. Well, we're going to choose the Java one today. And we're going to go down here to Robot Java Project. If you don't have WPI, I'm sorry, but that's going to be a little bit of a trek to get done. Once you are here, go ahead and click Next. Give it a project name. I'm calling mine Tutorial Bot. And now you'll notice that we have 3 radio buttons here. This top one is for command-based robot project. We're not going to do that until next week. The second line here is iterative robot. That's the one that we're going to select. Then, finally, at the bottom here is sample robot. It allows you to see some sample code. You can use it to copy and paste some examples into your project and generally get you on the road. But again, we're going to select iterative robot. Then you're going to click Finish. And eventually, it'll, I don't know what's popping up on your guys' screen, but over here on the left side is a package explorer. And if you don't have that, you can go over here to Window. Let's see which one. No, not there.
That's window. Window.
Oh yeah, Show View.
Show view.
And then in here will be a package explorer right here.
Wait, where? Oh, there.
Alt Shift Q or P is the hotkeys for it. And then this should pop up. And then inside Tutorial Bot here, you'll have a folder called SRC, stands for source. And then you'll have something called a package. It's labeled org.usfirst.frc.team, whatever you put on whatever your
Two numbers.
on whatever your team number is, .robot. Go ahead and open that up, and you'll have a robot.java file. Now, those of you who are unable to get to this spot, don't worry. Don't worry. What you'll do is just go to File, New, small icons. All right, go to New, Class, and then this will just allow you to. I would just at this point give it a name. Call it robot.java if you want. Or something that's creative. And then you just go ahead and hit finish. And you'll get something very basic here. And then you can just start here. I know, and as I said, you're going to have a lot of red squiggly lines. I know. It'll be all right though. If you if you write down exactly what I'm about to put down, it will work when you do finally get this and plug it in.
We need you to back up a little bit. When you did the new Java class, we didn't have anything to put in the source folder.
So we just put.
Well, just all you need to do is just put on. If you don't have anything there, you can just you just can give yourself a folder that you use.
And then put SRC.
You can just put in some kind of. Well, I suppose what you need to do is you need to probably make a project, but point being, just create a new class of some sort. But we're going to continue on as if we actually did have the WPI library.
We don't have the numbers, the 1, 2, 3, 4.
That's fine. So, no matter what, at this point, we're going to go ahead and continue onward. Now, line 16 here is the first line that we're going to look at. Public class robot extends iterative robot. And a curly brace. This is basic, and anything above this line is called the header. Okay? The header. What this line does is declares that you actually have a class that you're going to be writing. And it should already be set up for you. Should already have the public class, public class robot extends iterative robot. If you do not, go ahead and write that. And it doesn't necessarily need to be robot right now. Whatever your creative name was, go ahead and use that. And you'll probably come across a red squiggly line. That's mostly because you don't have access to the WPI library. Alright. Next, we have some lines here. This is actually pretty new for this year, but we're going to ignore them. So if you have them, just ignore them. Don't worry about them. Go ahead and give yourself some space below. Now the code that we're going to write it's going to look like this. Give you guys a better view of it, hopefully. Oh. No. You know, as a CSA for FTC, I like to come up with 30-second conversations. That just obvious because you have to discharge some capacitors for the robot. But thankfully, we didn't have to wait 30 seconds. This is what we're going to plug in down below the robot class here. Talon SRX, left drive, right drive, and arm. So let's go ahead and plug that in. Talon SRX space left drive comma space if you want right drive comma space arm. Now we're going to immediately get an error. As we hover over and go over here and hover over that error, we see a few options here.
Now, how do you know it's an error?
Okay, you see this red squiggly line underneath? See how there's a red squiggly line right there?
It doesn't look red to me, but that's good.
It probably, well, it's normally red because it's not selected, but it probably more magenta, I guess.
This guy, I'm colorblind, so.
But
Hey, same.
point being is there's a squiggly line underneath Talon SRX of some color. If we hover over that, we're going to see our first example of some quick writing techniques that we'll be able to have access to throughout this IDE, which, as remember, it stands for Integrated Development Environment. Now we have 7 available options here. We can either import from the library that was created by WPI, create a class, create an interface, so on and so forth. We have a lot of options here. What we're going to choose here is this first option here. So what we're going to do is just come over down here to import Talon SRX and then just click it. Now I want to show you something. Notice how we don't have a squiggly line there now. Great. The reason why is because right here in line 5 for me, this line got added. This is the easiest way to continuously import your project and other bits of source code into your project. It's a nice, easy way. Now, what did we just do here? What we did was we created something called a property. Not just a continue on the idea here. Wait for it. Alright, so properties are variables. If you, who here is taking and has used LabVIEW in the past? Any other programming language?
Alex too.
Yeah. Well, properties are then we'll go at this from the point of view of object-oriented programming. All right, so we have this thing called a class. What this is an idea that was created by C++ called object-oriented programming. What it really does is it allows us to be able to take something that some code that relates to itself. In this case, we have a robot, okay? We have some functions in this robot that relate to each other. And what that allows us to do is if we need to copy and paste this multiple times later on, or have something just load it into memory, we can do that easily by when we want by using a class. Now that's a little mumbo jumbo right now, but the important thing to understand here is that this is where we're going to be putting all our code. Properties are like variables when it comes to your code. We can change the properties of this class to fit our needs. For instance, let's say hold on. This is my favorite kind of example.
Blank screen?
Yes. Let's say you have a TV. Okay. Have a TV. Now, what are some differences in TV? Well, if you start looking at it from the basic view of technology, well, we have a screen. Right? We have a screen. And heck, we even have some sound. Okay? These are properties of this TV. Now, let's say we call this TV class. Okay? How can we leverage this into our understanding of TVs? Well, back in the day, there used to be an RCA TV, different branding, right? And they each would have their own kind of different kind of screen, right? Or different kind of sound. You know, Sony. Each brand has their own different kind of way of having a screen, having a sound. They have different features, potentially. Well, as we'll see, in a bit, that's something that we can also incorporate into our class. So, this is the basic idea of Java and object-oriented programming. This is what we're going to be doing all day, all night. Now, what this means is that we're going to have an object eventually, and it's going to have properties. Now, for these properties, we just defined for our robot. We defined motor controllers, and we're eventually going to do a few more things. From here, we can actually take these classes, these other classes or variables or properties, and modify them to operate our robot. So, for instance, we have a motor controller. Eventually, we're going to set the power based off of a joystick. So, what that'll allow us to do is be able to control our robot. Now, anything can be a property, except for its own class, really. You can take other classes and you can plug them in, like, say, motor controllers. But, too long didn't read. Properties store data. They store all your data of some sort. Okay? Questions? Sweet. Now let's go back to this this initial block of code. Let's continue and go ahead and put the rest of these items in. Alright, great. So, we're going to add robot drive. Robot drive. We're going to call it drive system. Again, squiggly line. Hover over it. We got a lot of, a few more options here. And again, we're going to choose the first one here. Just robot drive. Import robot drive. And just to show you again, when we go back up to the top here, hey, look it added itself. Great. Let's go ahead and add a joystick. Aptly named joystick. Okay, I'm going to call my joysticks drive stick and aux stick for auxiliary stick. What are we going to do here, guys? You see a problem, right? Hover over it, import it. Any questions on this process? Great.
So your drive stick and your auxiliary sticks are basically two joysticks.
There are two different controllers. So let's say you have two Xbox controllers. One of them is going to represent the drive stick. The other Xbox controller is going to represent the aux stick. Okay. Finally, we're going to go ahead and create a timer for when we actually have go to write our autonomous mode. And I'm going to call it auto time. By the way, I want you guys to notice something here. At the very end of each line is a semicolon. A semicolon ends a statement of code every single time.
It's like a
Now-
period. It's like a period, but it's not.
Yes, exactly. In our case, what we're doing is we're ending a line of code. You'll notice that there are some lines of code that don't warrant a semicolon, such as this public class robot extends iterative robot. But we notice that there's actually a bracket here. And we'll go over what brackets mean in a moment. But needless to say, that what we're working in is called a block of code. So, here we are. We have everything that we need to go ahead and create some kind of robot.
Sean.
Any questions so far? Any at all? Alright. Now, as was mentioned before, imported files allow us to actually take code from our library and use it in our robot. In our case, like the Talon SRX, or the joysticks, or the timer, or the robot drive. Not this week, but next week we are going to go ahead and get into how and where do we find these library files. So that way, if we want to read them and understand them, and actually draw code from them for our robot, we'll find where we can find these files for this library. Now, variable names. You notice that we made some names here. For instance, everything that is in blue on your screen right now is what's called a unique name. For instance, left drive, right drive, arm, so on and so forth. Now, and finally, what we're working on is something called object-oriented encoding. We're going to, as you'll notice, this is something that's going to be an overriding feature of everything that we do. Now, for those of you who, I know none of you programmed in LabVIEW, but in LabVIEW, you never really used object-oriented programming. You did something called procedural programming, where you actually have code running in blocks at a time. Let's say you had one loop for your drive system, another loop for your controls, so on and so forth. That was still considered procedural-based coding. Now it's multi-threaded potentially, but nonetheless, it's still considered procedural coding. In Java, we use object-oriented programming. Now next, we're going to go ahead and initialize everything on our robot now. So we're going to go ahead and go over these lines of code. So let's go ahead. Alright, now if we scroll down a little bit, we'll have our robot init right here. What this is called something called a method. Now, we've already discussed two different properties of object-oriented programming. Properties and now methods. Properties, as I said, is where we store all our data. Methods is where we go to manipulate that data to do what we want. Here, as you can see, we have a lot of code here that I'm just going to ignore for now. And we're going to add a line below it. So, the one thing that we need to do for every single item here is we need to actually do something called initialization. When you have any class in your robot, on any class that you're trying to call and make into an object, you have to be able to insert an object into that property. And that's what we're actually going to be doing right now. So what we're going to do is we're going to start with left drive. So we're going to type in left drive. And we're going to set an equal sign here. And now we're going to learn a new keyword. New. New is a keyword. Allows you to set a new object. And the object that we're actually going to select is based off of the actual item that we're calling. In this case, a Talon SRX. So we're going to type Talon SRX. And we're going to type in parentheses, open parentheses here. Now, if we hover over our little problem here, we see the constructor, Talon SRX, is underdefined. Meaning that we actually have to add some more to this. Now, the thing about any kind of method is that we can actually put any, and some methods allow us to input some data in. In this case, what it's going to be asking for is what PWM port your controller is plugged into. Now remember, 0 through whatever is on the controller are valid ports. So we're going to start out at 0. So we're just going to type in 0. And finally, does this line of code require a semicolon? Yes. So put a semicolon. Hey, look, an error-free line. Great.
So is the left drive just a variable that you put in there?
Okay, so what we're doing exactly is the following. We are setting left drive to equal a new Talon SRX class, and we're inputting a 0 into what's called the constructor. Now, we'll be going into constructors soon, but needless to say, what this is doing is it's taking our on the class that we're about to create and put it all into this left drive with the specific intent of it being plugged into the 0 port PWM slot on your controller. Okay?
So left drive can be any name you want to make it, right?
Yes. In our case, we're making it left drive. It could very well represent an arm or a shooter. Take your pick.
But hopefully the name describes what it is.
Yes. And I would suggest being very descriptive about what you're actually writing. And we'll go into writing comments in a bit. Actually, let's go into it right now. So if you want to just write great code, you will want to comment your code and describe exactly what you're doing. In this case, I want to describe what we're doing on this line. So we have a, come on. There we go. We can use a double slash symbol to denote we're actually going to write a comment. Now comments carry no weight in a compiler. The compiler explicitly ignores whatever you put here on beyond this line, beyond this double slash on this specific line. In this case, I want to describe what we're doing here. Well, we're creating creating the left drive variable on property. Pretty descriptive, I think. And heck, and we can also say we're plugging it into port 0 on the controller.
Okay, so what's it?
Pretty descriptive, I think. All right.
Because you guys know what port 0 means on the Robo-Rio, right?
All right. So we're gonna create another line,
It says
and in this
PWM
case,
wire, 0.
we're going to create right drive. By the way, make sure when what you put up top is what you put down here. Specific case specifically too, because Java is case sensitive. Java is a case sensitive language. What are we going to do here? Well, we're going to do what we just did above. We're going to equal new Talon SRX in parentheses, and we're going to say port 1. Again, does this line warrant a semicolon? Yes. And heck, let's go ahead and create another comment here. Creating the right drive property and plugging it into port 0 on the controller.
You mean one, don't you?
Let's say RoboReel.
You do mean port 1, right?
Oh, yes, sorry. Port 1. All right. Now for some fun. Now let's do that drive system. So, drive system. All right. What do you guys think? What do we need to do here? Pretty much do what we did above. Instead of calling it Talon SRX, though, it's robot drive. So we're going to create a new robot drive. And now let's go ahead and put our parentheses in, and let's take a quick moment to take a look at what we can do here. Now, if we hover over our robot drive error here, we have a lot of different options here. The first one here, int. Interesting. Int stands for integer. What we can do here is we can set our ports directly this way. Now, for those of you who whose teams use the talons on the CAN talons, it's important to you to know that you can actually derive all on your actual. You can pull your encoder data off of those controllers. Well, if you're not using CAN talons, there's a bit of a shortcut you can take here, but later.
You're like Victor.
But what we can do here is take a look at line 3 here. By the way, line 2 here is if you have four-wheel drive. But look at line 2 on 3 here. Add arguments to match robot drive, speed controller, speed controller. We just defined 2 speed controllers. It says Talon SRX though, right? Well, one of the cool things about Java is so as long as they fit a certain idea, certain kind of class idea, they can pretty much replicate those ideas. Now in this case, we have 2 Talon SRXs. Those are speed controllers. So it's asking for speed controllers. So we can actually put in our left drive and our right drive. Now, important thing to note here, the first speed controller typically denotes the left drive. The second one denotes the right drive usually. So we're going to use that same notation here. So we're going to just type in left drive, comma, right drive. Oh, case sensitive.
Spacing doesn't matter.
Spacing does not matter. You can make this all one word. The important thing here is to note that you have to have a comma there. And heck, if you want to be wild and zany, oh, come on.
Nope.
This also works. Notice how I just put one on another line. What is important here, however, does this line of code require a semicolon? Yes. This is perfectly valid. Because what happens, so if you have a big kind of constructor or something on kind of method that requires a lot of inputs, you can put them on separate lines, so that way your code is a little bit more readable.
So you just hit enters or you
Yep.
just added spaces?
You can actually put in on put a return in. What this does, what actually is going on here, is that the robot on the code on the compiler reads line by line, pretty much, sort of. Once it encounters something it can't solve, it will actually go ahead and try to look for that resource potentially. Well, what's going on here is that, well, on line 482 here, is we have drive system equals something on some kind of robot drive, and it sees an end of a line. Does it see a semicolon? In this case, no. So it goes down to the next line of code, and it continues on until it actually sees a semicolon, and it does here. That's the important thing here, is making sure that you have semicolons. Now, for posterity's sake, I'm going to just keep it to one line. And I'm going to write a comment, because commenting is good. So what are we doing here? We're creating the robot drive to be used in our robot. Great. So now we need to create some joysticks now, right? Hey, guess what? Same methodology here. Joystick. No, sorry. Drive stick
Okay.
equals. Okay, I did get the case correct. Drive stick equals new joystick parentheses. Now, we're going to go ahead and do this again. Gonna hover on over. The argument that we want is this top one. The bottom one, I don't quite remember exactly what it does. I don't use it ever. But basic idea is that we want to use this first one, and we're going to enter in a USB port. Again, this year they've introduced USB port 0. So we're going to go ahead and type in 0.
So that's for your computer?
Yep. This is for your driver station. And again, not to beat a dead horse or anything, but does this line require a semicolon?
No.
It absolutely does. Come on. This line of code is not that special. I'm sorry. But we're going to go ahead and write another comment. Creating the drive controller on port 0. Spelling is sometimes hard for me. And by the way, you can actually, it will allow you to do some basic spell checking, just like here. Do you guys want to guess what we're going to type in this line of code?
Joystick.
Uck stick.
Auxiliary stick, yeah.
equals new joystick, and we're putting it on port 1. Yes, we need a semicolon.
Okay. The 0 and 1, does it really matter where you put it? It just assumes the first one you put in.
Okay, so so you guys understand what this actually represents. When you go into your, let's see if I actually have it on my desktop here. Driver station, yes. I do have the driver station. Wait for it.
Here it comes.
Does this look familiar to you guys?
Yeah.
Cool. Alright, let's see, it's not that one, it's this, no, it's this one right here, this fourth option here.
USB order. Okay.
We'll go over that in a bit. Now, you'll notice that on the bottom left corner here, we have something called USB order. Well, here's a physical representation, the actual representation of this in from your robot, your driver station. Now, remember, you can actually drag and drop these. So let's say if you want controller 1 up in 0, you just drag and drop it on up. Any questions? Cool. Moving along. Finally, we had that timer, right? Let's go ahead and create the, we need to create a comment here. Always gotta do comments.
Why does your comment below there only have one backslash? Is that because it's on a new line?
This one down here. That is actually a different way of commenting. That's what's called block. It's a block comment. So what you can do, just to go over this real quickly, you'll notice how it's a /* here.
Yeah.
Just to make it somewhere to look at. We have a /* here. And typically what you'll see in block style comments, in IDEs, they will typically put in stars every single line. And then to finish off that block of code, you have a //. Okay? So this whole, from 49 to 57 here, is a block of comment. So it's a good way, and it's good practice to, if you need to type some kind of long explanation about a method that you're creating, or some kind of variable or something that requires a bit more explanation, this is a great way of doing that. So that way you can use multiple lines at once.
So you couldn't use.
Do multiple lines with the...
Oh, you certainly can, but you have to start every single one of those lines with a double slash.
Okay,
Oh, okay.
gotcha.
For
You
instance,
could have skip a line and it was okay.
well, you can skip a line
Oh, but not
for code.
For code, not for
Not
comments.
for
For comments, however, it is based off of that line. A double slash is based off of that line. So, like, for instance, this is good. This is not.
Yeah.
Makes sense.
It's just different ways of commenting. All right. We have one last item to initialize. It's that auto time. So we're going to type auto time equals new timer. And you'll notice we don't initially get an error when we put that semicolon in, because this actually doesn't require anything special. It's just a timer. It knows what it is.
So are the parentheses automatically showing up when you say timer? Or you have it in?
I entered it in. Well, since it's an IDE, you enter in the open parentheses, it'll automatically put the close parentheses. But you always need them. You always need the parentheses. Any questions?
So there's nothing inside the parentheses then?
Correct. Let's go ahead and put in a quick comment on timer that it will be used for auto mode. Great. Anybody have any questions whatsoever right now? Are you guys getting it so far? It's a little bit muddy. I'll admit it's a little bit muddy right now to understand the whole object-oriented programming aspect of this, because it is a very complicated subject. Really, it's only up until recently have I actually really understood it. And I've been programming since I was 7 years old.
So the first block up there, you're just saying like tell an SRX, you're just initializing all those variables? Is that what-
Yeah, we're just creating variables, but we also have to be able to put something in them, because initially there's nothing in here. They're just empty. They're just empty little variables. They're a little sad too, just because. But once you actually put stuff in them, they're happy. You can actually use it. But until you actually put everything in, you can't really use these.
So then what is public void mean then?
Okay,
Yes, always have public void.
not necessarily. There are times when you can do whatever you want, but the term public void, let's start on these are two of these, and these are both keywords. Public, what that means is that you can use this anywhere. Use this method anywhere.
Basically, go-
Void means it will, you cannot, and you will not return anything from it. Now, eventually, when you start working with some of these variables, you'll notice that you can return some things. Like for our joysticks, you can actually return like your axis on the position of a joystick axis. Well, that allows you to take some kind of value from one place, from one method, and put it into either a property or a method of your choosing. Sort of what we did with defining these, on initializing these Talon SRXs. But in this case, for our robot init, we're not really returning anything or putting anything in. We're just calling it.
So all of this is initializing all your variables in it?
Yes, exactly. So that way we can actually use it. All right. So again, we have our properties. We have to put some data in them before we can use them. And the robot init method is always called in something called the first loop. So the first time your robot is ran, it will run this method every single time. That's something that you can count on. Now, methods, we've already talked about it a little bit, but methods are the heavy lifters of object-oriented programming. They actually do stuff. They take things from one place and put them in another. Take data from one place, put it into another. So they carry boxes essentially. So it's a dichotomy that you'll understand when it comes to any kind of programming, is that you have variables that you have blocks of memory that you're trying to write to, and then you are writing some kind of program to manipulate that memory to do what you want. That's the basic idea here. Now, just to quickly go over on a diagram of these lines. We have ourselves our left drive here. It's what we call our object. Okay? We got that from our property when we described our properties up top. New is a keyword. States that a new object is about to be made. And then finally we have our class initializer, also known as a constructor. And in this case we were passing a PW imported. Now down here we're actually passing classes into a class. Now that's something I find that's really cool to just understand, is that you're actually taking a class, some kind of object, and passing it into another object. So that way it can be used in some kind of meaningful manner. Alright, so now for that shortest IntelliOp mode in the world that involves 3 motors.
Okay, do you want to take just a 5-minute break?
Yeah, let's go ahead and take a 5-minute break.